We're going to start with a new program and we'll just call it timers. And under controllers, we're going to select our Micro800 PLC, which is a 2080 LC20 20QWB. And we're using version 12, and I highly recommend that you have at least version 12 because it uses that Logix theme that we've been using throughout our videos. We're going to select it and add to project. And then we're going to right click programs and we're going to add a ladder diagram. So let's go ahead and open that up. And we're going to put a direct contact instruction or an examine if closed instruction. And we're going to go to switch 1. In fact, let's go ahead and flip our trainer around. So switch 1 is a toggle switch to position, so it'll be easy for us to turn an input on, see what happens, turn an input off, see what happens. So let's go over to our I/O Micro820 tab, and it is going to be input number 8. And while we're here, let's go ahead and label that as switch 1. And now we're going to insert a timer instruction. Now, yours may not look like mine because maybe you haven't figured it out yet, but you can click these tabs and drag them around, which is really nice. By default, your timer tab is like somewhere way over here. So just use these left and right arrows to go through your tabs and find that timer tab. And for me, I drag it over here because it's one that I use often. So I'm going to put it right beside this bit tab. And now we're going to bring a TON instruction down. And while it looks like you need to add a tag here for the preset, you don't actually have to. This is actually one of my favorite features of the Connected Components Workbench software compared to RS Logix 500 or Studio 5000. And those you would need a time base such as, say, 1 second, a tenth of a second, or a hundredth of a second, or thousandths of a second. And then you would have a preset value. So you had to do a lot of math to figure out exactly what your timer is. In Connected Components Workbench, you can simply type T $, and then if you want a 10-second timer, you can type 10S. Or let's say you wanted a 10-minute timer. You can type T $10M. Or if you want an hour, it can be T $10H. So it's going to do all the math for you. Now you're probably thinking, well, how am I supposed to remember that? Well, if you highlight that TON instruction, then press F1, it's going to bring up the help section. And it's going to give you some info about the timer, and it's going to give you kind of a really vague thing right here that kind of says, oh, well, there it is. But it doesn't really ever nail it down. But come on down to the bottom, it says time data type. And if you'll click it, then here is your cheat sheet to figuring this out. So first we can see the maximum timer time is going to be 49 days, 17 hours, 2 minutes, 47 seconds, and 294 milliseconds, which at least from my point of view seems like an abundance of time considering RS Logix 500 was what, 9 hours or so? So excellent amount of time. But more importantly, here are those codes. So if you put T $, and then a D, that's going to be units of days. H is units of hours. M, units of minutes. S, units of seconds. And MS, units of milliseconds. And what's even better is you can use combinations of those. So right here are some nice examples of it. T $, 1H, 450 ms is going to be 1 hour, 450 milliseconds. Also, you can do it in longhand form. Instead of T number, you could actually do time number. They do the exact same thing, but 1H 3M is going to be 1 hour, 3 minutes. This is an outstanding feature that they've added to the Connected Components Workbench software. So we're going to make our timer 10 seconds. And now let's go ahead and go to our local variables, because each time you add an instruction like this, you're going to end up with a local variable for that instruction. So here's TON_1. And if we actually look at this TON, it says TON_1. So that's it. We open it up, and then we have the IN, and that's what precedes the instruction, which right now we have to switch 1. And then we have these other two Boolean instructions. We have this Q instruction and we have this reg instruction. So let's go ahead and add those to our program. Let's create a new rung and let's go back to our bits tab. and use that direct contact examine if closed. Oops, and I put it in the wrong place, but that's okay because you can drag them around. And here, let's type TON, and there goes _1 dot Q. And let's make that turn on light 1. So we'll go to direct cull, output energize, and then let's go to our IO tab. And we're going to use output 0, which is wired to light 1 in our getting started exercise. Let's go ahead and label that as light 1. And while we're here, let's go ahead and label the next one as light 2, light 3, and light 4. And all right, that will be light 1. And then let's highlight this where it's highlighted blue here. Let's right click it and copy, and right click paste. And let's make this that reg. And let's make it turn on output 1 or light 2. Okay, and our program's ready, but we've forgotten one critical step. We need to configure our Ethernet address. By default, CCW is going to download a program that's configured for DHCP, but our trainers are configured for a static IP address of 192.168.110. So we don't have to fight DHCP again. Under our project organizer, let's click on that Micro820, and let's go down to the Ethernet. And yours may not look like this. If yours looks like this and has this picture of the PLC, hit this double arrow right here. It'll get rid of it and kind of give you a little more room. But instead of obtaining an IP address automatically, we're going to configure ours for 192.168.110. And then we're going to click the subnet, and it's going to automatically fill in 255, 255, 255.0, which is going to work great for our application. So now we're ready to download our program. So let's click the download button. And we'll go ahead and download our program. Okay, so our program is downloaded. Make sure over here on this Micro820 tab that you are in run mode. And let's look at our program, and let's just switch 1. All right, we get light 2 on. 10 seconds later, we get light 1 on. Okay, so let's just do that again. Make sure we understand what's going on. So I switch 1 on, and light 2 immediately came on. And if we wait 10 seconds later, light 1 comes on. So the reg bit means that the instructions preceding the timer are true. Or in the case, if you're coming from Studio 5000 or RS Logix 500, it means the timer is enabled. The Q bit, which we have wired to green, means that elapsed time is greater than our preset time. Now, so elapsed time, if you're coming again from Studio 5000 or RS Logix 500, elapsed time is accumulated time, and preset is preset. So let's go over here to local variables, and let's just open up this TON group while we're here. And let's go ahead and switch that off, and we'll switch it on again just so we can see. And our N has a check by it, and your reg has a check by it. And we can see our elapsed time going up, and as soon as it hits 10, then yes, we get a check by it. And we have this P date here, and this P date is what it's going to use to actually track time. So just to review again, the reg bit here means that these instructions preceding this timer, or whatever's going into this N right here on our TON, is true. The Q means our elapsed time is greater than or equal to our preset time. Now, if you're coming from Studio 5000 or RS Logix 500, there is a bit that is missing. And this little bit never got much respect in those softwares either. It was actually never even shown on the instructions. So a lot of you are gonna be like, what bit is this? But there was a TT, or a timer timing bit. So if you're doing a conversion from RS Logix 500, for example, that was using this, it'll be important to know what that was. And so the TT bit said that an instruction was true, but the accumulated or the elapsed time was less than the preset time. So we can add that pretty easy. So let's go ahead, let's go offline here. Let's just copy rung 3 and we'll paste it in. And we're gonna leave this just like it is, the reg bit. But now let's add a reverse contact or an examine if open right here. And for its address, let's put the TON_1.Q. And let's make this output 2, which is connected to light 3. So again, we've already determined that our Q means that our timer is enabled and our elapsed time is greater than or equal to our preset. And our reg bit means that the timer is enabled. So what we're going to look for here is that our timer is enabled, but our preset is not greater than or equal to our accumulated. And that's going to end up being the timer timing bit. So let's download that. Okay, and you saw some action on our lights as soon as we downloaded. So let's switch one off. And now we'll switch it back on. We're going to see right away light 2 and light 3 come on. Now this is our timer timing. We think this is our preset. So when this one goes off, light 2 should come on, which it does. So if you need the timer timing, for a legacy program or just in general, if you need it, then that's how you can get it. That's the TON in a nutshell. We're going to go through it more in depth in later programs as far as like making sequences happen and things. But let's move on to the TOF or timer off delay instruction. So let's go ahead and go back offline and let's click back on our timer and counter tab. And right there is the TOF instruction. So let's just drag it down, so right beside of it. And we're gonna go ahead and take out though, this TON instruction. Now right away, we're gonna get some errors through here. You see we got some yellow marks. So let's go back to our local variables and see what's available. So open up our TOF. Okay, so we have TOF, we have a Q, now we have a fledge. And so let's change these around and see what works out here. Let's go to our program. So here we just need to change this to TOF. Here we'll need to change to TOF and we're gonna need to make that a fledge, which does stand for falling edge, by the way. I don't really like that nomenclature because it's not the falling edge. But we'll get to that more at the end of the video. I don't want to cloud this too much. So we'll change this one also to TOF and we'll make it that fledge. And then we'll make this one just TOF and the Q is fine. All right, one thing I forgot is that preset. So let's put that back at 10 seconds. And do you remember how to do that? It's gonna be T number and then 10S. Let's go ahead and download that to our PLC. Okay, so let's go ahead and switch one. All right, and we got light 1 and light 2 on right away, and that's connected to the Q and the fedge. All right, and then light 3 is not coming on, which that was to compensate for not having that timer timing in the connected components workbench. So let's switch it off. And our elapsed time immediately starts going up. Our fedge bit went out immediately. And 10 seconds later, our Q bit is gonna go out. So let's do that again just so we can see it. First, switch it off. We switch one on. And our Q bit and our fedge bit are on right now. We switch one off immediately. That fedge bit, which was the light 2, goes out. 10 seconds later, and we can see our time accumulating upward here. And yeah, it goes out. So there's one big thing. This is a TOF or timer off delay instruction, but the elapsed time goes up just like a TON would. It's not a countdown timer. But what's different about its timing compared to the TON is when it times. So a TON times when the instructions preceding the N are true. A TOF will time when the instructions preceding the N are false. So right now, if we switch one on, which is going to make this true, we're not going to be timing. When we switch it off, which will make this timer false, then we're going to start timing it up. And that's one thing I love about the TOF is it's one of those clear instructions that tells you that every instruction does something, whether it is true or it's false. There are very few instructions that do nothing. So let's try to clear up what these bits are. After we're timed out, we definitely see no lights on. We switch 1 on, and immediately light 1 and light 2 are on. And that's our Q bit here is on light 1, and our fetch bit is on light 2. So when we switch 1 off, immediately light 2, which is this fetch bit, is going to go out. And then 10 seconds later, the Q bit is going to go out. The fetch bit is telling you that the instructions preceding the timer are true. So that's why the moment we switch 1 off, that drops out. The Q bit tells you that the elapsed time or the accumulated value is less than the preset time. So we switch it on, it's on right now. And that's because the moment we turn this on, this timer goes to 0. So it is going to be less than 10. So the Q bit is on. We switch 1 off, it's going to start timing up, but it's still less than 10. And that's why the Q bit is still on until it hits that 10 seconds. And then it's going to go out. So how does this one work if you're coming from, say, RS Logix 500? In the TOF, the fetch bit is going to be your enable bit. Turn it on, the fetch bit is immediately true. Turn it off, the fetch bit is immediately false. That is the enable of a TON in RS Logix 500. So then what is the Q bit? Is it the done bit or the timer timing bit in RS Logix 500? Well, it's actually both, and I'll put a link to my lesson on RS Logix 500 timers, which shows that yes, the timer timing and the done bit operate exactly the same way on a TOF. So this bottom rung that we had made for the timer timing of the TON isn't even necessary for the TOF. Let's move on to the RTO instruction. Let's go offline and let's drag this RTO down. And let's delete this. And now we'll keep our preset at 10. So that'll be T $10S. And then let's go ahead and go to the local variables so we can see what all is available for the RTO. So in this one, we have a reset instruction, the Q, the reg, and the fetch. So let's go ahead and add them. Let's just start. We have the Q here, so let's make this RTO. And then we have the fetch, it's already there, so we'll make this one RTO. And then go ahead and delete that examine if open or reverse contact, and let's make this one the RTO reg. Okay, and then there was one other bit in there that we didn't see when we were browsing here, and that's the RST or reset, and it's up here on the instruction itself. And to show what it's gonna do, let's go ahead and use button 4, which is input 7 on our trainer. So let's type in _IO EM, and then we're gonna want a digital input, and we want number 7. So let's go ahead and download that. Okay, and right away we got a few lights here. There's probably a way to expand these fields a little bit, but yeah, they're kind of truncated there. In the description, somebody told me how to make this a little wider so I don't have to mouse over them. With switch 1 off, right now our elapsed time is at 0 and our fetch bit is on. So let's switch this on for about 2 seconds. Mainly, let's pay attention to this elapsed time and of course our bits, which you can look at the lights. That's why I like wiring with the lights. I can kind of catch it a little quicker. So 1, 2, off. All right, so light 3, which is the reg bit, came on while switch 1 was on, and light 2 went out. And also, okay, our elapsed time went up to, all right, I was a little fast, 1 second and 780 some milliseconds. But mainly when we switched it back off, it did not clear out. So now let's do that again for 2 seconds. So 1, 2, off. Okay, now we're at 3 seconds and 500 and some odd milliseconds, so about 3.5 seconds. And again, when we switch one on, this reg bit turned on and this fledge bit turned off. So let's do it again, just so we can see about 2 seconds. 1, 2. We gained about another 2 seconds on this timer. So every time this is enabled, it's accumulating time. But unlike the TON instruction where it's not enabled, it clears out the elapsed time value, the RTO doesn't. It has this separate reset. In fact, let's just go ahead and reset it right now. Even though we haven't made it to our preset time yet, let's just hit that reset and we're back at 0. So switch one on, we can stop it, switch it on again for a while, stop it again, and this time let's just go ahead and switch it and let it run on up. Again, the reg is illuminated, our fledge went out, and when we hit 10 seconds, our Q bit came on. So let's switch one back off now that our Q bit is on, or mainly that our elapsed time equals our preset time. So the reg went off, the fledge went on. So the fledge, or the falling edge bit, means that the instructions preceding the RTO's end bit are false. The reg bit, or rising edge, means that the instructions preceding the RTO are true. Now, I don't like the rising edge and falling edge, and yeah, I still want to kick that can a little further down this video before we get to it. So that's why I've started calling them just fledge and reg, because they're not edges. Well, yeah, this probably is a good time to talk about it. So the fledge is for falling edge. Well, in my opinion, that is the moment that the switch switches off. That is the falling edge. So it should only be good for that one little bit, but no, it continues on like the one-shot falling. That is good just on that one edge. That's what an edge is. So I don't really like those terms. That's why I just started calling it the fledge and the reg, because it's not a rising edge, it's not a falling edge. But let's go through it one more time just to make sure we understand. So right now light 1 is on because the RTO's elapsed time is greater than or equal to its preset time. And right here we can see we're at 10 seconds. It doesn't matter where this switch is at this point, whether this timer RTO is enabled or not enabled, that light's going to be on. Now, the reg bit is going to be whenever this is enabled, and the fledge bit is going to be whenever this is not enabled. So the biggest difference between the RTO and the TON is that the TON resets that accumulated time whenever it is disabled. In the case of the RTO, it has this external reset that will reset it. While the TON and TOF, they're pretty easy to understand applications for. You know, let's say we had a cylinder that we needed to extend for 2 seconds and then do something and maybe retract. Those are where you would use the TONs and TOFs. Probably the biggest example of the RTO instruction is a runtime counter. So how much is the machine actually running? So when we're running, we're counting. Machine stops, we're not. Run, count, stop, not. So it's a great way to see one machine utilization. Also, maybe a machine needs a certain part maintained every 100 hours. Well, that would be a good use for an RTO timer as well. Okay, let's go on to the next type of timer. Let's go ahead and go offline, and let's change this to the TONOFF timer. Let's drag that down. And this is another great addition to the Connected Components Workbench, this TONOFF timer. Let's go ahead and delete that out of the way. And let's put a preset time. Let's stick with our same one. It'll be a T number 10S. And then it has this preset OF time. Well, that is the preset off time. So let's put it at, well, let's make sure it's different. So let's go with T number, let's go with 5 seconds. Okay, and then let's look at what bits it has. So just type TONOF in there, _1, dot, and there's that fedge again. Let's get it in there. And then the next one was the Q. And then finally we have the reg bit. And let's go ahead and download that program. So let's play with this and see what we get. Right away, our fedge bit is on, our Q and our reg bits are off. Let's enable our timer. our reg bit immediately comes on. Our Q bit isn't on yet. And 10 seconds later, it does come on. Notice that the fetch bit stayed on the entire time. The reg bit came on when we turned switch 1 on. Now let's switch it off. And right away, both of these went out. And 5 seconds later, the fetch bit came back on, the Q bit went out. Let's do that again just to make sure we see it all. So switch 1, immediately our reg bit turns on, our fetch bit is on, our Q bit's not on yet, and it's gonna come on. Now we're gonna switch it off, and the Q bit is gonna stay on. Both of these, the reg and the fetch went out, and then 5 seconds later, that fetch came back on. Now that was a lot of regs and fetches and everything. Let's talk through exactly what is going on. So this is a T on off timer, and I'm gonna go ahead and give you an application for this that I see the need for it so often, and that is on a basic pump control that has a single float that's in turbulent water. And you guys have seen them before. They're bouncing up, they're bouncing down, and people put those narrow angle floats on and pumps on, off, on, off, on, off, on, off, on, off. So what this is gonna do, let's just concentrate on the Q bit for a second. So we switch 1 on to kind of say that the float's coming up. And okay, is it bouncing or is it solid on? And that's what we're really seeing here. Once we know that it's solid on, it's gonna come on. And now our pump would turn on. But okay, it's turbulent, so it drops off. Well, we don't want that pump to immediately kick back off. So this is gonna make that pump stay on for that extra 5 seconds. And this is gonna really save the life of a lot of your components. So the big thing here is this PT, that's the time that that timer must be enabled before this Q bit comes on. Then this PTOF is going to be the time that the timer has to be disabled before it'll turn that Q off. So to really help in those applications, say, well, another good example would be heater applications where, you know, the thing's just on, off, on, off, on, off, on, off. You know, it'll save those component lives if, you know, it could be on a little longer, off a little longer. Okay, now let's look at that fetch and that reg bit. Because one thing I don't like, go to program variables, and let's look at the definition of those. So drag this back out. All right, there's our reg and our fetch bit. And it says reserved for internal use only. Well, these bits have a lot of good uses if you understand how to use them. So let's go ahead and concentrate on that fetch bit. So our switch is off and our fetch bit is on. We switch 1 on, that enables our timer. Our fetch bit is still on. And we're gonna let it time up to 10 seconds and it's gonna stay on. We switch 1 off, and immediately that fetch bit's gonna be off. So what this bit means, and I didn't talk fast enough, but 5 seconds later it comes on. But what the fetch bit ultimately means is that the timer is not in that little off state window. So let's watch that again. So timer on, fetch bit's gonna be on. Keep going. 10 seconds later, we get our time bit. Okay, the moment I turn this off, this light's gonna go off. So this is that small 5-second off part of that timer. So let's say that in addition to that pump running, you're also pumping a chemical in, but you need to make sure that all that chemical's out before you turn that pump off. Well, there is that little window there. So that's a really important one to understand. So now let's look at this reg bit here. So the reg bit is not on right now. We're gonna switch 1 on, and immediately the reg bit is gonna come on. And it's gonna stay on after the Q bit's on. The moment we turn it off, the reg bit is gonna go off. So the reg bit means that the conditions preceding this timer are true, just like the enable bit in RSLogix 500. But using these 3 bits, you can figure out that the timer is enabled, but hasn't reached that 10-second mark. You can figure out that it has reached that 10-second mark. And then you can also figure out that no, the timer is disabled, and is in that off time, or the timer is disabled and the off time timer is done. Now that's a little confusing, but I'm actually going to make a separate video talking about this just for these applications where people struggle with things turning on and off so much. You get like 6 months out of a contact. This is an excellent instruction for taking care of that in one line of code. Okay, and finally there is one more type of timer instruction. So let's go offline and let's go to this TP, which is a pulsed timer instruction. So let's bring it on down. Let's delete this out. And all right, we'll stick with our same preset time, which hopefully by this point in this video, you can remember how to put this in. T number 10S, that's gonna give us our 10 seconds. And then let's just type TP. And let's see what bits are out there for it. So this one has only the Q bit and the reg bit. So we'll go ahead and delete this last rung out. All right, let's download that. Okay, and so right now our timer is not enabled because switch 1 is off, our Q bit is off, and our reg bit is off. So let's just really quickly switch 1 on and back off. And our Q bit comes on immediately, our reg bit's on immediately, and our timer did not stop timing when we turn switch 1 off. And that's what it means by pulse timer. So this timer only needs to be true for one scan to enable it and stay enabled. And so the moment you switch it on and back off, now the Q bit is gonna stay on until the 10-second timer is done, and then it's gonna go out. Now the reg bit did not go out. What the reg bit says is that the timer is enabled. Now this is a little tricky on this pulse timer because watch, if we switch it off, obviously we're not enabled. We switch it on and back off, well now it's saying that we're still enabled. We are, and that's because that pulse enabled that timer until the elapsed time is greater than or equal to the preset. Now it's gonna go out. If you leave that one on, then 10 seconds later, it's gonna stay on. The Q is still gonna go out. Now, one other thing to make sure you understand on the pulse timer is when you're enabling it, now you can switch this on off as much as you want during that 10 seconds, and it will not affect the timing of that timer. So that's a really good thing for, capturing the edge of something, needing the time 10 seconds, shoot a box out of the way on a conveyor or something like that. We'll probably play with it a little more in some of our machine sequence exercises.